Good morning. I am Marita Kotze, Senior Education Specialist at Impact, and I'm going to give 2 minutes for all the attendees to log into the system, so please be patient. And while we're waiting, I will repeat that in any case, but make sure that you download all the notes um, after the session. And yes, and if you do have any questions, that you will send it through to me, that I can attend to that after the session. So let's just give another minute. So for the attendees, I can see that more attendees is busy logging into the system. So okay, there's still more. You can see on the screen to the right or below on your screen. You can see there are a board where you can choose some things, and there's a hand that you can click on to show me that you can hear me. So you can click on that. Um, can you please click on that to show that you can hear me properly? All right. Thank you, thank you, thank you, thank you. Thank you for all the hands. Okay, let us just start. All right. I am Marita Kotze, Senior Education Specialist for Physical Sciences at Impact, and I'm going to give you a few tips today on physical sciences. Okay, right. I saw this photo is my favorite. If you attend my lesson last week, um, you will see that this is again here. And I hope this photo let you dream about your future and, yes, taking science to places and give you a new vigor for learning science for a science career. So yeah, learners, I hope I can help you today to give you more understanding of physical sciences. All right, so a few things before we start with this webinar. Uh, I will deal with your questions after the session, not during the session. So make sure if you do have any questions, you can write it in the question box to the right or below on your screen, and I will deal with it afterwards, and I will send an email with my answer through to you. Okay, remember to write all your questions in the question box. Then the other thing is all the notes that are put on your handout box to the right or below. Um, make sure that you download the notes. The notes are exam papers about the session that we're going to do today. So make sure that you do download that. The memorandums of the papers you can download it from the guided learning platform. And if you are not from Impact, not the Impact learner, you can send an email to info at Impact and they will forward it to you. Okay, then the handouts are question papers for Doc Scientia. So make sure that you learn or go through your work and then you work out the question papers and then correct your answers by using the memorandum afterwards. Attendees, I really want you to ask me some questions, and if you do have some questions, make it relevant to the work we're going to do today. And if if you don't write any questions in the question box, please send an email to academics@impact.co.za. All the handouts will be on my Impact, not my Impact, it will be on the guided learning platform. The YouTube video, you can go to the Impact YouTube channel for recordings of this session. And any other questions you can send through to academics@impact.co.za or Impact. All right, our knowledge area that we're going to cover today are matter and materials. Matter and materials. Okay, and the topics that we're going to cover is the kinetic theory of gases, ideal gases and thermal properties, Boyle's law, Charles' law, and Gay-Lussac's law. The three laws that you see here at the bottom are the laws that you will see how they interact with each other as well. So now, what is the kinetic theory of gases? As you can see, gas particles are far apart from each other. There are spaces and they spread out to fill the container. That is normal gases. Normal gases, and the gases around us, the oxygen that you breathe in, and the nitrogen and all the other gases that's in the air, all of them are far apart with large spaces between them. Particles have also potential energy due to the attractive forces and repulsive forces exist between. There are potential energy in each and every particle, and repulsive forces exist between them, and kinetic energy is due to their movement. If they bounce or repulse each other, then they move and we have higher kinetic energy. So what is happening with the gas particles? They are constantly moving and colliding with each other, and they move with a Brownian movement. The Brownian movement, there are more about that in your study guides, but the Brownian movement are fast and random motion. There's no exact movement for a gas particle. Okay, and what is the relationship between temperature and kinetic energy? Now, if the temperature is low, you will see the particles are nearer to each other. It's not so far apart, but the moment that you increase the temperature to 487 Kelvin, they are far apart. They're further apart. So temperature is directly proportional to kinetic energy. Gases with a higher temperature have more kinetic energy, and gases with a lower temperature have less kinetic energy. So more kinetic energy means faster movement, therefore it's a higher temperature. So the ideal gas model. What is the ideal gas model? An ideal gas model is a hypothetical gas which obeys all the gas laws for all values of temperature and pressure. So now let us look at a few gases that we do have, like nitrogen gas, hydrogen gas, helium which is a noble gas, and the ideal gas. I'm going to differentiate between the two now that we can see how they differ from each other. But here you can see the two gases that are near to ideal gas, or the two that nitrogen is not near an ideal gas, while hydrogen and helium, they are the two gases, that are the nearest to an ideal gas, the performance of hydrogen and helium gas. So the kinetic theory, we said all matter consists of particles and they are constantly moving and colliding. We just take that now. We say that there are repulsive forces that exist between particles. Now, the ideal gas volume theory says that there are such a big or distance between the particles that have no volume. While the kinetic theory says the gases that's been in a container, they do have volume. So the ideal gases don't have any attraction or repulsion forces between the particles. The particles are identical, while the kinetic theory, uh, it's not necessarily identical. The number and intensity of collisions of gas particles determine the pressure. Um, no attractive and repulsive forces, so no pressure. The average kinetic energy of the particles is a measure of the temperature. So it's the same with the ideal gas theory. A real gas behaves like an ideal gas at a low pressure and high temperatures. Low pressure, there will be no volume in low pressure. High temperatures, they will be far, far, far apart, so there will be no attraction or repulsion forces, and collisions between them will be completely elastic if there are any collisions between them. All right, now Boyle's law. What is Boyle's law? If we look at Boyle's law, we can see if a gas is held at a constant temperature, it's very important that the temperature must be constant. The volume is inversely proportional to the pressure. As you can see, we do have a hyperbole curve here. So if the volume is big, the pressure is low. Think about gas or a syringe, okay? A doctor's syringe. If we do have little pressure in it, the gas is also, the volume is little pressure, the volume is big. If you start to increase the pressure in the syringe to inject the patient or inject somebody, then you will see by increasing the pressure, you're decreasing the volume in order to inject the patient. Okay, so what is happening with the graphs in Boyle's law? We do have a hyperbole curve. The two are indirectly proportional, inversely proportional to the pressure, the volume and the pressure. If we show a straight line graph, then you can see the quantity of the gas remains constant, the temperature remains constant, and therefore a graph of volume versus 1 over pressure will then be a straight line graph. Okay, that is extrapolated here. It is not 0. Can you see this? It's not 0. Okay, now Boyle's law. Other graphs that we do have at Boyle's law, if we do have P multiplied by V, we say that P multiplied by volume equals a constant. If we look at the previous slide, we can see here P multiplied by V equals a constant. So here we can see, since if we do have different gases, then we can say P1 V1 equals P2 V2. If we do have a gas with different volumes and different pressures. Okay, so Boyle's law graphs for different temperatures. Can you see here, if it's high temperature, the pressure increases, or the volume decreases if it's high, the high pressure. Okay. All right. Charles' law. What is happening with Charles' law? Charles' law, as the temperature increases, the volume increases. Can you see here the volume and the temperature? If the temperature increases, the volume increases. There's a straight line graph. The volume, because the faster molecules collide harder and push each other farther apart. Can you see here? If the temperature increases, there's no pressure here. The pressure the temperature increase decrease the pressure here. So the volume T V is the volume of the gas, T is the temperature, K is a constant. In our V is therefore directly proportional to the temperature, as we see here. Now, what is Gay-Lussac's law? Gay-Lussac's law says that the pressure exerted by a gas is directly related to the Kelvin temperature. Okay, so now we have temperature, pressure, and Kelvin. In the previous the previous law, we can see we have Charles' law. It's volume and temperature, and Boyle's law is pressure and volume. So if we have Boyle's law and Charles' law, and now we have Gay-Lussac's law, we have pressure and temperature. Pressure and temperature, as the temperature of enclosed gas increases, the pressure increases. Okay. Okay, now we have mathematical formulas. We say the absolute pressure of a given mass of a perfect gas varies inversely. All right, we do have the different relationships between the pressure and the volume is inversely. Volume and temperature is directly proportional. Pressure and temperature is inversely proportional. It's directly proportional. Now, what stayed constant with Boyle's law? The temperature. With Charles' law, the pressure, and with Gay-Lussac's law, the volume. So, combined gas law equation. We do have a combined gas law equation where we combine the pressure, the volume, and the temperature. We get it from our formula P multiplied by V equals K multiplied by the temperature. So the pressure multiplied by the volume equals the constant multiplied by the temperature. So pressure and volume can be in any unit of measurement as long as it is the same unit on both sides of the equation. Here is an example. We have a sample of nitrogen gas that has a volume of 0.8180 liters, 0.180 liters at a pressure of 0.800 atmospheric pressure and a temperature of 29 degrees Celsius. What is the new temperature in degrees Celsius of the gas at a volume of 90 milliliters at a pressure of 3.20 atmosphere? So now, how do we do this? Write down what you do have, your solution. Write down what you do have, because this is confusing now. We have two pressures, we have two volumes, and we have one temperature, and we need to calculate another temperature. So by using the combined gas law, first, by writing it down, you have to change it, because volume must be in milliliters or cubic decimeters. So here we change it to the liter into milliliters, and we have the temperature in Kelvin. So what do we have here? Now we can state by using our formula and substitute everything. By substituting everything, then you get your temperature on the one side and you do your calculation. But now you have your temperature in Kelvin here. All right, so what's happening here? You have a temperature in Kelvin. By having a temperature in Kelvin, and you need to answer the temperature in degrees Celsius, you need to subtract 273 Kelvin in order to get your answer in degrees Celsius. All right. What is the general gas equation? That is another gas equation that we do have that you need to use, but they are very important in this gas equation. Now, remember, we we do have now mole here. As you remembered from last year, your grade 10 quantitative aspects, N is the symbol for mole. So if the quantity of gas is indicated in moles, then we use this formula. The value of K is different for different quantities of gases. So yes, for PV equals K multiplied by T, P multiplied by V. The value of K is different for different quantities of gases. So now, if the quantity of a gas is indicated in moles, you need to remember you have to use this. And you have to use the formula for mole. You can look that on your formula sheet. Please remember that you can take your formula sheets from your March test paper, and by working, if you are busy with calculations with chemistry and physics, take your formula sheets, because that are the formula sheets, the information sheets that you receive that are attached to your exam papers. If there are any formulas that are not on your formula sheet that you know that you will use, write it on your formula sheet. And by writing it on your formula sheet, additional, you have to learn that. So make sure that you write down formulas that's not on your formula sheet that you will use. All right. Now again, let us just see here. R is an universal gas constant, and a constant means that it will always be the same. So the universal gas constant is 8,3143, and it's also on your formula sheet. Make sure that you notice where on your formula sheet is it. And N is the number of moles. So very important here, you have to change pressure into Pascal, volume into cubed meters, and temperature into Kelvin. So make sure that you know how to do the conversions. You can see in front of the quanta books, there are lists to show you how to change decimeters, cube decimeters into meters, cube decimeters, cube centimeters into cube decimeters into cube meters. So yes, make sure that you know how to do it. You will find it in front of the quanta books. I will tell you a bit later about the quanta books again. All right, a few hints here. Write what is given and asked, and what is asked. Do your conversions here where you write what is given already. So when you substitute in your formula, you will not make any mistakes. By changing temperature in Kelvin, you have to take your degrees Celsius and add 273. And as we see in the previous example, if you have to change it Kelvin into degrees Celsius, you minus 273. See what formula, after you write down what is given, see what formula is best for what is given and asked. Substitute all the values, give your answer with the correct unit. Please, learners, you need to answer with the correct units, because if you do have an answer without a unit or without the correct unit, you will not be rewarded any marks for that. All right, so now let us look at an example for using the formula, this gas formula. A rigid container of volume 4 cubed decimeters. All right, can you see? Write down 4 cubed decimeters, changing it to cubed meters, already changing it there. Contains 4 grams. All right, is the mass. Write down 4 grams at 300 Kelvin. It's already been changed to Kelvin. What mass of oxygen should be injected in an identical container? So now the volume of the container is identical. So for the oxygen calculation, you can use the volume of the hydrogen gas because it's identical. Yeah, but the oxygen gas is in degrees Celsius. Now you have to change it into Kelvin, so you just add 273 to get it to Kelvin. Now again, so what is asked? They asked what mass of oxygen gas. So write down mass oxygen gas required. So the first thing is you need to work out the pressure of the hydrogen gas. Why? Because we don't have the pressure in our formula. We don't have the pressure for the uh, um, oxygen. So by calculating the pressure for the hydrogen that you can use, why can we use the same pressure? Because it's the same container. So that's why we can use the same pressure and the same volume. Then let's make sure that you do understand that. All right, how do we calculate the number of moles? We calculate the number of moles with the formula M divided by M. That is your formula from your formula sheet. The mass given is 4 grams. The molar mass for hydrogen gas is 2 mole. Is 2. So therefore the mole will be 2 mole. So now we can calculate the pressure. You first write the formula, substituting each and every number and calculate the pressure. You can write it either in Pascal here or kilopascal. Or it must be in Pascal, but you can either write it like this or you can write it in scientific notation, mathematical notation, but please make sure that you know how to do that. Okay, and in this, just make a note that you must remember that you don't round it off here. You use, although you write it down here as a rounded off number, you have to use the unrounded number in your calculation here. So although I wrote here 1,25 multiplied by 10 to the 6, that pressure must be used to the number of moles. Now we do have the number of moles of the oxygen gas. Because it's the same container, it's the same pressure, we can use it. So now we can calculate by using the same formula that's on the formula sheet. Now we manipulate it to get the formula M equals Nm. A mole multiplied by the molar mass. Please, learners, first write down the formula as it is on the formula sheet. Then you manipulate your formula. If you do manipulate it, you can just use that formula. So now we have the mole multiplied by the molar mass of oxygen. How do we get the molar mass of oxygen? The molar mass of oxygen is 2 multiplied by 16 because the relative atomic mass of one oxygen is 16 grams per mole. So for the molecular mass, it's 32. So it's 2 multiplied by 16, and you do have your answer. All right. So it depends. Can you see? It depends if you use a rounded off number or an unrounded number, what the answer will be. All right. Something that I want to state here that's very important. You will see there's a term STD. It's the standard temperature. And STD is the standard temperature and pressure. So the standard temperature and pressure is 273 Kelvin, and the standard temperature of pressure is 101,3 kilopascals. So you the kilo, remember, is multiplied by 10 to the third. 10 to the third. All right. So now All right, let us look at a summary of the gas laws. We have Boyle's law. It's P1V1 equals P2V2, P multiplied by pressure of 1 multiplied by volume of 1 equals pressure of 2 volume 2. It must be a constant temperature. As the pressure increases, the volume decreases. So the relation is inversely proportional. So what is happening with Charles' law? Constant pressure, as volume increases, temperature increases. Gay-Lussac's law, at constant volume, pressure increases, temperature increases. Combined law, where we combine the three of them, we obtain this formula by combining Boyle's law, Charles' law, and Gay-Lussac's law. And then the ideal gas law is P, V equals nRT. Volume must be in cube decimeters, temperature in Kelvin, pressure in kilopascals. N is the N is number of moles, and R is the ideal gas constant. All right, part B of this webinar is the chemical change. All right, we start with quantitative aspects, and that is what we're doing today. We're doing the quantitative aspects. It's the basic concepts of and basic constants of chemistry. So what is the quantitative aspect? Okay, we have mass, concentration, volume. All right. So we have in chemical reactions, we have reactants and we have products. And we can calculate the moles of the reactants and the moles of the products. Now, this you already did in grade 10. So make sure if you're a bit unsure about this word, that you download the grade 10 notes of Science Clinic as well, and just go through that, but it's also in the Science Clinic notes. So make sure that you do know how to calculate all these calculations. Now, what formula do we use for mass? It's mole equals the mass given over the molar mass. Right. So concentration equals, it must be small c. Concentration is mole divided by capital letter B. So volume equals, and volume. Now what is this 22,4 cube decimeters? That is the volume at ST to STP. Okay, standard temperature and pressure. It is 22,4 cube decimeters. All right. Although we're not really using the triangular method anymore, this makes such a lot of sense for me for how to use that in any case. How to calculate mass of moles, volume of a gas, and volume of a gas of a solution to moles. So it is moles equals volume divided by the molar volume, and mole divided by concentration and the volume. All right, I include the periodic table of elements for you because this is a very important table that you need to know and understand how to apply. When doing your bonds, when writing chemical equations, you need to know and understand the periodic table. This is a tool that you get for free. But so often I find learners that don't know how to use the periodic table, and why are the periodic table in their hands. So you, for once, you can derive the ion number from your periodic table. For example, all your group 1 elements will have an ion charge of 1 positive when they're giving away 1 electron in an ionic bond. Your group 2 elements will give away 2, so the ion charge will be 2 positive. Group 3, 3 positive. Group 4 will be 4 positive, 4 negative, but they share, so they will not have, they're not necessarily well, but they will share either, they will share in any case 4 electrons. And we use carbon covalent bonds in organic chemistry. More about that later in the year and next year as well. All right, then your group 5, they will take 3 electrons, will have an ion charge of 3 negative, 2 negative, 1 negative, and your noble gases here will don't have any charge. Now, your transition metals here in the middle, they decide what the ion charge will be, either 1 positive, 2 positive, 3 positive, or some of them will also have 4 positive, it depends. This is a table of cations and anions that you get in your grade 10 here. If you're not knowing your anions and cations, please learn this. Ask your mother, ask your teacher, ask your tutor to explain this to you if you're not sure to use this to write your formulas. Because in grade 11 and 12, they will give you the name and you need to write the formulas. And these are the tables that you use to write the formulas. So, as you can see here, hydrogen, lithium, sodium, potassium, all 4 of them, they are in group 1 on your periodic table. That are the elements, the ion charges you can derive from the periodic table. The same with beryllium, magnesium, calcium, barium. Tin, lead, chromium, manganese, iron. Can you see all of them from there, from tin? All of them do have a Roman numeral of 2. So what's the meaning of that? The Roman numeral of 2 is meaning that it's 2 with ion charge on them is 2 positive. All right. So what then with aluminium? Aluminium is in group 3. So that's 3 positive. Chromium, iron, and cobalt, all 3 of them, they are transition metals. So please, they do have. Can you see there's an iron 2 as well? So make sure that you can write the formulas. Chromium 4 and manganese 4, it's 4 positive. Again, you do have a manganese here and you have manganese there. Make sure that you know how to write the formulas. Your anions, it's more complicated. Here you can see if your anions, oh my goodness, there are 2 or more elements that combine together to form a radical combination, but they do have a negative charge. So again, make sure that you know your ions here and how to write formulas. Ammonium is the only positive with 2 elements combined. All right. So now, basic concepts of chemistry that's coming from last year: the atomic number, the mass number. What is an element? I'm not going to waste time on that. And isotopes. Remember, what is isotopes? It's different atoms of the same element with different mass numbers. All right, so they all have the same relative atomic mass they do have the same amount of numbers, but they have different relative atomic masses. So you have carbon 12, carbon 13, and carbon 14. Here they show, but all of them do have the same number of protons, but different neutron numbers. So therefore, they are isotopes from each other. All right. So the relative atomic mass and relative formula and relative molecular mass. All right. So, and the molar mass. What are the difference between these 4 different names? If I say you need to use the relative atomic mass, it's as it is on the periodic table. You derive it from that. The relative atomic mass of carbon is 12. That is the biggest number on the key of carbon on the periodic table. So the relative atomic mass don't have any units, so we just say there's 12 units in 12 grams of carbon. Right. So relative formula and relative molecular mass. Again, there's no unit. How do you calculate what's the difference between a formula and a molecule? If we do have ionic compounds, can you see here nitrate is NO3 2 negative. So NO3 negative. Nitrate is NO3 negative. Calcium is 2 positive. So two nitrates will combine with one calcium. All right. So we cannot say it's the relative it's a relative molecular mass because it's not a molecule. No, it's an ionic compound that forms an ionic crystal lattice that forms. So it's the same thing. We use the same symbol for both of them. It's just a different name for the same thing. Okay? When it's a molecule, it's a relative molecular mass. When it's a formula, we say it's a relative formula mass. All right. By calculating them, we have 18 units. You just add, take the relative atomic mass on the periodic table, multiply it with the number of the elements that you do have, and add them together to get your 18. Now, what is the molar mass? All right, molar mass is mass in grams of 1 mole of particles. All right, more about the mole concept just in the next slide. So what is 1 mole? So we said particles. It can either be atoms, molecules, or formula units. Again, molecules, covalent molecule, formula, it's a compound. Okay, what is the molar atomic mass of carbon? It's 12 grams per mole. What is the molar molecular mass of water? 18 grams per mole. And what is the molar formula mass? Can you see it's the same thing? We calculate it here. The moment we ask the molar mass, we just add unit gram per mole. Gram per mole. All right. What is a mole? As we see here, if we take 12 grams of carbon, carbon is charcoal. When we have bride today or tomorrow, just weigh 12 grams of carbon for yourself so that you can remember that is 1 mole. It's 1 mole. So what is 1 mole? 1 mole of matter contains the same number of particles as there are atoms in 12 grams of carbon. Now your particles can either be atoms, molecules, or ions. It depends on your molecule or compound, ionic compound, or if it's atom. So here we do have 4 different elements. We have carbon, copper, and sulfur, and mercury. All right. If you I take the keys that are on the periodic table, I take it and show it here. So if we say 12 grams, the relative atomic mass in grams, that is 1 mole. The relative atomic mass in grams is 1 mole. Relative atomic mass of sulfur in grams, that's 1 mole. And the same with mercury, the relative atomic mass as it is on the periodic table in grams, that's 1 mole. All right, so what is Avogadro's number? If we state and we say, all right, we have now carbon, and we say this is 12 grams, and that is 1 mole. How many particles are in 12 grams? That is Avogadro's number. We say, if we look at the previous slide, we have different grams here. Can you see that each and every one of them is 1 mole of that substance? Now, what is Avogadro's constant then? We can say here, if we do have 63.5 grams of copper, it will have the same part atoms, number of atoms as 12 grams. has 32 grams, has 201 grams. So again, so what is Avogadro's constant? Avogadro's number is 1 mole of matter that contains 6,02 multiplied by 10 to the 23rd elementary units. So it can either be atoms, molecules, or ions again. All right, as there are atoms in 12 grams of carbon. Remember, it's a constant. It's also on the formula sheet. Not necessary to learn it off by heart. You can read it from your formula sheet. Can you see? You need to use your formula sheet. That's a tool, learners. So therefore, atoms in 1 mole of carbon contains 6,02 multiplied by 10 to the 20th atoms. If we have 1 mole of carbon dioxide gas, it also contains 6,02 multiplied by 10 to the 20th carbon dioxide molecules. All right. If I ask you to calculate the number of atoms in carbon dioxide molecules, you still need to multiply it by 3 because there are 3 atoms in one molecule to get to the amount of atoms. So now we look at ionic compounds. If I have 1 mole of sodium chloride, 1 mole of sodium chloride contains 6,02 multiplied by the 10 to the 23rd sodium chloride formula units. So, an example here, how many molecules are 3,91 grams of ammonia? First, you have to calculate the number of moles in order to use your formula. From your formula sheet, N equals N divided by Na, where N is the number of molecules, N is the number of moles, and Na is Avogadro's constant. So, here is just a relationship between mole mass and atoms of elements. So make sure that you know the difference between the mass of an element. If you have to calculate the mass of the element, you need the number of moles and the molecular mass as you read it from the molar mass as you read it from the periodic table or calculate it if it's a molecule or an ionic compound. Okay, the formula for N is number of atoms divided by Avogadro's constant and N. All right, so make sure that you do know the relationship between all these formulas and what each and every one stands for. Okay, now the concentration of solution. Here, I can see learners battle with that, but again, your formula is on your formula sheet, and this can also be calculated with concentration. If you need to calculate the number of moles first, you can either use this and your formula to calculate your number of moles to get to your concentration calculation. That is, you can either use that formula or you can calculate first the number of moles and then just substitute your number of moles after you calculate the number of moles to get to your answer, and it's mole per cube decimeter. All right, what is molar volume of gases? Molar volume of gases is the volume occupied by 1 mole of molecules of the gas, and you can see again at STD at standard for STP, N equals V divided volume divided by molar volume, where molar volume is 22,4 cube decimeters. All right, you can also use the mole ratio to calculate to get in your chemical reaction to get to your uh, uh, volume. All right, now let me just state this again. I see I still do have time here. So please, learners, if you do have a chemical reaction and you do need to, say, for example, calculate the number of or the volume of the ammonia gas here, you can get your ratio from your chemical equation. It's 1 mole, 3 moles. There's not a 1 before the nitrogen gas. So it's 1 mole nitrogen gas. The 3 mole is from there. So your mole ratio is 3. And your number of ammonia is 2. The 2 in front of the ammonia molecule states there are 2 moles of ammonia. Right. So therefore, if it is at standard temperature and pressure, you can just use your ratio. Or if it's not, you can, in any case, if it's not standard temperature and pressure, you have to calculate it. All right. So here you do have, again, they can also ask you to calculate the number of hydrogen gas or the volume of the hydrogen gas if you do have. So for example, if they state that you do have 1 mole here. All right. Now, additional resources for physical sciences, I do include it again today for the learners that not from Impact or didn't see my webinar last week. So here we do have Doc Scientia. We use it, in fact, we use Doc Scientia's textbooks, the Quanta books, and the Science Unit notes. So what is the Doc Scientia textbook study guide? All right, in this study guide, you do have summaries. So learners, please make use of the summaries after each unit, use of the mind maps, as well as the question papers that are on the in the question box that we loaded today for you, the question papers. And if you need more question papers, you can order it as well from Doc Scientia at the store. There is the link that you can use for the website where you can order it from. Okay, one other thing that Doc Scientia has that is a very useful tool is the experiment videos on a memory stick that you can order from them. They do have all the experiments that's in the study guide, videos on a memory stick for you, and they explain the scientific method after each experiment. So please make sure that you buy your memory stick with the experiments on it, especially if you don't have any photos to do the practicals. So please make sure that you order it and look at the practicals, and it will make life much easier for you. Doc Scientia also sell exercise books that you can use with question paper questions, exam type of questions in it. Now the Quanta books, the Quanta series, the Quanta books you received, the Impact learners received the Quanta books with the physical sciences packages this year. If you didn't use it yet, please start to use the Quanta books. There are 2 DVDs at the back of the Quanta book, as well as the information sheets that are also in the Quanta books for you. And on the 2 DVDs, there are a total of 8-hour lessons. No, not every lesson is 8 hours. It's a total of 8 hours on the 2 DVDs. But especially the ideal gas laws that I did today, there's like a 10-minute animations to show you the difference between the 3 laws. It's very good, and she also explained it's a qualified science teacher. Also explained the different graphs that can be asked in an exam. So please make sure that you look at the videos and then start to do the exam type of questions that is in the context summary. There's also summary, and there's also exam type of questions, multiple choice questions as well as longer questions. Very important is the multiple choice questions that's been explained in the memorandum at the back of the content book. And lastly is the science clinic notes and exam seminars. Now, learners, these are smart prep books, and it's really good. It's summaries of the whole year's physics as well as chemistry. Very good summaries with all the graphs that you need to know from grade 10 as well. You can see all the different graphs, and especially last week's the free body diagrams. Very good in there. Download it, it's for free from their website. Go and download the summary book, and then you can also register for the exam seminars that they do have during the year. You can go on their website. Here's the link, and during the year they do have exam seminars for the June exam. I'm not sure if there will be June exams this year, as well as the prelim and end of year exam. So go on their website, see where it's nationwide. They do have exam seminars, and you go on their website and see if there are a location near your town or your farm where you live. So thank you, learners, for attending today's class, and I really hope that you find this that this will help you. And please make sure if you do have any questions or any suggestions to write it in the question box to the right or below at the end of the session as well. So please make sure that you write your questions and send an email to academic@impact.co.za. Or if you're not a registered learner with Impact, you can contact Impact at impact.co.za to get the notes, and you can go on. Remember, you can go on Impact's YouTube video channel to download the video, to look at the video again that adds, as well as last year's video. Okay, and remember to ask your questions, and I will answer your questions. Thank you very much for attending today's class.